we will spend some time thinking about how to graph quadratic functions. So first we need to recall that the general form of a quadratic equation is a times x squared plus bx plus c set equal to 0, where a, b, and c are real numbers, but remember a cannot be 0, otherwise it's not quadratic. A quadratic function is simply a quadratic equation set equal to another variable. So using function notation, a quadratic equation in the variable x, where y is a function of x, is denoted by f of x equals a times x squared plus bx plus c, and that follows the same rules as we have outlined for our quadratic equations, where a cannot be 0. There's another form of a quadratic function which is called vertex form, and this is something we're going to explore, as it's going to be very helpful for us in terms of understanding the structure of our quadratic function. So we've talked about this before, that the graph of a quadratic function is called a parabola. And every parabola has a vertex of the point h, k. So the h value is the x-coordinate, the k value is the y-coordinate. There are other particular properties of parabolas that we're going to explore at a later point. And one is that if a, the leading coefficient, is positive, then our function is going to open upward and the vertex is going to be a minimum point. The minimum value of the function will be the k value. If a is less than 0 or negative, then the parabola will open downward and the vertex will be a maximum point, and the maximum value of the function will be that k value again. We also have the axis of symmetry, which is the vertical line x equals h, and this vertical line will always pass right through the vertex. So let's look at a couple of general forms of a parabola. For the first one, we see our parabola is opening upward with a minimum point and a minimum value. And for our second one, our parabola is opening downward with a maximum point and a maximum value. For this video, we're going to focus on the vertex of our quadratic functions. So we're going to examine quadratic functions to find the vertex, which is, again, either the highest point if it opens downward, or the lowest point if it opens upward. And we're going to do so in two ways, and we're going to split this across two videos. So the first method, we're going to look at quadratic functions which are in vertex form. Vertex form is f of x equals a, which is our leading coefficient, times the quantity x minus h, quantity squared, plus k. And the vertex is going to be identified by recognizing the value of h and the value of k. So for example, for our first function, f of x equals x squared plus 3. This is in vertex form, even though we don't have parentheses, because if we think about what's happening to x, we could write this as x minus 0, quantity squared, plus 3. Therefore, we can identify that h is 0 and k is 3, and so the vertex is 0, 3. For our next example, this is in vertex form, where we can identify h is 4 and k is 2. So our vertex is 4, 2. Now this one is a little bit different in the sense of Our A is -1, so that means that this parabola is going to open downward. And so our vertex is our highest point, 4, 2. For our next example, because our leading coefficient is positive, that means that this is opening upward. And then we have to be a bit careful here. Remember, the vertex form is x minus h quantity squared. So for this particular example, that means h is -4 and k is -3. And so our vertex is -4, -3. You have 2 questions. Identify the vertex for f of x equals the quantity x plus 2 squared. And for your second question, again, identify the vertex for f of x equals 2 times the quantity x minus 4 squared minus 7. We're going to continue with method 1 for finding the vertex, but the question that we must ask ourselves is, what happens if our function is not given in vertex form? Well, we have 2 choices. We can either abandon this method and move on to the next method that we're going to cover for finding the vertex, or we can actually get the function in vertex form by completing the square. So we're going to run through the steps of how to get this in vertex form. And the first step is to identify the terms that contain variables. So for this example, it is x squared plus 4x. So we're going to leave this -5 or -5 alone. And so for our first step, we're going to complete the square by recognizing x squared plus 4x is a binomial. And to create a perfect squared trinomial, we need to identify b, which is 4, take 1/2 of it, which is 2, and then square it, which gives us the result of 4. So notice I'm adding 4, but I'm not allowed to do that. I have now unbalanced this equation. So instead of adding 4 to the left side, which would be awkward because this is a function, I'm going to balance this by subtracting 4. And then notice we had a -5. Notice here, this is a perfect square trinomial. This is x plus 2 times x plus 2. And then because we balanced this by both adding 4 and subtracting 4, I have our new constant, which is -9. So this is now in vertex form, and I can identify that h is -2. Remember, vertex form is x minus h. So h is -2, and our k is -9. So our vertex is -2, -9. For our next example, we need to do a touch more work, because if we look at our 2 variable terms, we have a common factor of 2. So our first step is going to be to factor out that 2, which then leaves us with x squared minus 4x. Now, every step, I want you to notice that we really haven't changed anything. I made a little mistake there. X squared minus 2x. Hopefully you caught that as well. So as I was saying, every step is the same. It's just going to look different. Now our focus is on completing the square here. So we're again recognizing that b, in this case, is -2. We're taking half of it, which is -1, and then we're squaring it. So now we have 2 times x squared minus 2x plus 1, but we need to balance this by subtracting 1, and then our constant -5 trails along. Now notice this is a perfect square trinomial, but we have this to contend with as well. And notice it's in the parentheses, but what's outside our parentheses is this 2. So if I want to write this in vertex form, I have to recognize that I want the x squared minus 2x plus 1, our perfect square trinomial, to be alone. But then we still have that -1, which is also impacted by the 2. And so distributing that, it gives us -2. And now this is in vertex form, noticing that I can factor my perfect square trinomial. I can combine my constants. -2 minus 5 is -7. And now, finishing my vertex form, we have 2 times the quantity x minus 1 squared minus 7. So that gives us our h of 1. Our k is -7. So our vertex is 1, -7. And I'm going to lead you a bit more than I usually do for rewriting this function in vertex form so that you can identify the vertex. I'm going to start you out with recognizing that we have a negative that we need to factor out. So that gives us the negative of the quantity x squared plus 4x and then plus 2. And so now we're ready to complete the square. And we did this up above. So b is 4, 1/2 of 4 is 2, and 2 squared is 4. So we're going to add 4, but also subtract 4. And that plus 2 drags along. And so now we have our perfect square trinomial of x squared plus 4x plus 4. I want to close my parentheses there, and this is where I'm going to leave you. What do I have to do with that balanced -4 so that I can finish this and identify my vertex?